All right, welcome to class. What we're looking at today is some of the exercises in Basic Circuit Challenge. In the full Basic Circuit Challenge program, we're going to look at the things on the left side. These actually are the items that are in the Basic Circuit Challenge Lite program, which is free. So let's get started. Here's Basic Circuit Challenge Lite. And if you looked at the picture before I switched, it said this was the items that were in the left column. Right column items, they're in a full version of the program. So I'm going to tell you how to get past each of these items. We'll start with electric ideas. Okay, electric ideas is the basic theory of electricity and how it works. So it's things like understanding that like charges repel, unlike charges attract, how the electricity and electrons move. They go from negative to positive, and how they move through conductors. The force goes at the speed of light. The electrons themselves, a few inches a second. The methods of producing electricity, you have chemical sources, that's batteries. Electromagnetic is that those are your generator stations. Piezoelectric, which is vibrating to create it. Photoelectric, which is your solar power, and thermoelectric, converting it from heat or cold. Then you have your basic relationships here: voltage, current, and resistance. The voltage in the circuit drives the current. Voltage goes up, current goes up. Voltage goes down, current goes down. Resistance is an inverse relationship. If you increase resistance in a circuit, you decrease current. If you decrease resistance, you increase current. So once you go through these tabs here, you hit begin, and it's 25 questions. They're always the same. I'm not going to go through them. I said to save time on this video, but my basic advice is memorize them. They never change. Next one, electric ideas. Electrical components. Okay, electrical components are the items, the different type of items that make up electricity or to control it. So here you have a switch, symbol for a switch. There's what a fuse looks like, symbol for a fuse. Next one over. Here's resistor symbol, potentiometer, adjustable resistor. Here's what resistors tend to look like. There's what a potentiometer tends to look like. Then you have your capacitors. Here's a symbol for a capacitor. Here's all the different shapes that capacitors can be in. Then we have your inductors. You got two types. You have air core, which is this, looks like the fist. And then you got the iron core, fist with the two lines. The two lines indicate that it's wrapped around iron. And then last, we got semiconductors. Semiconductors being transistors. You have your transistor symbols down here and what the transistors tend to look like. Integrated circuit, LEDs, diodes, and diode symbols. Just like the electric ideas, 25 questions, never changes. My advice is still the same. Get through them, memorize them, and you'll have no trouble with it. Then let's look at color codes. Okay, color codes is how you read the value of a resistor. They said they have color bands painted on them. The colors represent numbers. Black is 0, brown's 1, red's 2, orange is 3, yellow is 4, green is 5, blue is 6, violet is 7, gray is 8, and white is 9. And then you have another set of colors that said, which are silver and gold, and they represent tolerance for the resistor. So if you have no tolerance band, this one's not here, it's 20%. If you have a silver band, it's 10. If it's gold, it's 5. Let me show a few of these. Anytime I do this, I always do show color names because otherwise the monitor that you're looking at may or may not be good. So this first one here, we got brown, green. Okay, brown is 1, green is 5, and then black. Black is 0. If black is in the third color position, you add 0 zeros after the first two numbers. So in this case, it said it's just 1 and 5. And then that second block, the tolerance, well, that's silver, so that's 10. Let's do this next one. Orange, orange, orange. Okay, orange is 3, so 3 and 3. and then 3 zeros, and then gold, 5. One more example. Red, violet, so 2 and 7. Orange, 1, 2, 3 zeros, and none, which is 20. So there. So that's how you do the color codes. Now let's look at Ohm's Law 1. Ohm's Law is the controlling theory for electronics. And what Ohm's Law states is V, for voltage, is equal to I, current, multiply resistance. The current in a circuit is equal to the voltage divided by resistance, and resistance in a circuit is equal to voltage divided by current. So how you do this exercise is when it comes up, you have 2 blocks that show in red and one that's in a bluish. So if it's V that you're looking for, you just take I and multiply them times R. So 6 times 7. That's 42. Okay, now it's asking for R. So R is V divided by I. So 15 divided by 5. So that would be 3. And now it's asking for I, which is V divided by R. So 28 divided by 4, and that's 7. And that's how you get past these. That's the Ohm's Law 1. Related to Ohm's Law is this last one, electrical power 1. And electrical power is equal to current times voltage. Now, they have some other formulas here, but I always just like sticking with basic Ohm's Law and not doing the things that involve exponents. So wattage is equal, that's the power, is equal to V times I. Well, they didn't give us V, but remember V is equal to I times R. So in this case, 3 times 4, that's 12. Then it'll be 12 times 3, or 36. Okay, this time they gave us V and I, so it's 8 times 4. So that'll be 32. Once again, they didn't give us V, so it's 2 times 4, that's 8, then 8 times 2. You get the answer, 16. Okay, they gave us the 2 this time, so it's just 25 times 5, 125. Same thing as that they gave us V and I, so it's 5 times 10, 50. Okay, this time they didn't give us I. I is equal to V divided by R. 6 divided by 3, which is 2, then 2 times 6, which is 12. So that's how you get through the power one. That's all for now. Have a great day.